Hello and welcome to economics class. Today we are going to see a segment of statistics which is called measures of central tendency. These measures of central tendency are tools that are applied to study and analyze a data. As we know that economics is always dealing with data in terms of the interaction of the economic agents, either between the buyer and the seller or a corporate organization, or even between country and another country. So because of the nature of the data that we are confronted, we have to be applying some tools to analyze the data. Among the tools is the measures of central tendency. It consists of mean, and in some cases is called arithmetic mean. And mode, and finally median. This consists of mean or arithmetic mean, mode, and median. So these tools, we are going to see how they are calculated and how they try to describe the data. Number one, when we say mean, it refers to the average of a given observation or data. That means the item that is neither high nor low. That means in between, the average. So this mean is calculated as, or is represented by this symbol. And the symbol is pronounced as X bar. So this X bar is found by calculating the sum of X over N. This symbol that we are seeing is a Greek word pronounced as sigma. And it means the sum of something. So as it appears here, it means the sum of X. And what we mean by X, we mean individual item of the observation. So whenever we are given a data, any item is represented by X. So we try to find the sum of all these X by having this symbol. Then N. This N means the number of the appearance of each item of the observation. So this formula is only applied when the data is raw. That means if the data is not organized. But if the data is organized, then we use another formula. For example, if you are given a group data, so the mean will look like this. Sum of fx over sum of f, where this f represents frequency. But up now, we are going to use the first formula because we are going to use the raw data to find the mean. Now, suppose we are given data 2, 3, 4, 1, and 5. This is the data, this is the observation we are given, and we are asked to find the mean. The first thing we are going to do is to look at the data. Which one is the highest and which one is the lowest? Then we start with the lowest. Then we say mean is calculated by having the sum of X over N. Now, each item of this data is represented by X. So here we have X1, X2, X3, X4, and X5. So we have 5 items of the observation. Now we know the number of the appearance of each item because each item here appears only once. So the next thing we are going to do is to take the sum of these figures. Then we said 2 plus 3 plus 4 plus 1 plus 5 all over. Then we count their number of appearance. 1, 2, 3, 4, 5, represented by this N. So we have 5 here. Then we say 2 plus 3, making 5. 5 plus 4, 9. 9 plus 1, 10. 10 plus 5 is 15. So this 15 divided by 5. 15 divided by 5 is 3. Therefore, our mean is equal to 3. So when you look at the observation, then you locate which one is 3. This one, this is our mean. And as I said, whenever you are given data, especially if it is raw, then you look at the highest and you look at the lowest. Here, the highest value is 5, while the lowest one is 1. So between the highest and the lowest, then you look at it and find which one is the average, that is in between them. If you take 2, then you know that it is somehow low, but it is not exactly the average number of the observation. So that is how to find mean, find the mean of this observation. So from it, we can understand that there are some items that repeat themselves. So how are we going to find them? If we use the same process that I use now, definitely it will look somehow difficult. But what we are going to do is to multiply them according to their number of appearance. For example, we say mean is equal to 1 times how many number does 1 appear? Only once. So we multiply it according to the number of the appearance. Then we say 2. 2 appears only once. Then we have 3. 3 appears 2 times. So we multiply it by 2. Then we have 4. 4 appears 2 times. So this one too, we multiply it by 2. Then we have 5. 5 appear only once. Then finally we have 6, which also appears only once. So we divide them by their number of appearance. We said 1, 2, 3, 4, 5, 6, 7, 8. So that is their total number of appearance. So we now say 1 times 1, we have 1 here, plus 2 times 1, 2, plus 3 times 2, 6, plus 4 times 2, 8, plus 5 times 1, 5, plus 6 times 1, 6, all over 8. So 1 plus 2, we have 3. 3 plus 6 is 9. 9 plus 8 is 17. 17 plus 5 is 22. 22 plus 8 plus 6, is 28. So we have 28 here divided by 8. So when we divide 28 by 8, we have 3.5. Therefore, our mean is equal to 3.5. But you can say, among the items of the observation, there is no such number. Yes, so that usually happens. But if you have a result of finding a mean that has a reminder like this one, then you don't have to bother yourself. As long as you use the same process and you have your final answer is correct. So that is how to find mean. Now, the next thing is mode. When we say mode, we mean the most frequent value of an observation. Any item that appears more than others then is referred to as mode. Or it can also be defined as any item that has highest frequency. And we know that frequency is the number of the appearance of each item of an observation. Now, suppose we have this information or data and we are asked to find the mode. As I said, mode is any item that is most frequent than others. So then we now apply what we call frequency table. And I'm sure that you are familiar with how to construct a frequency table. Now, this X represents each item of the observation. Then we start with the lowest. We have 1. 1 appears only 1. Then we have 2. 2 appears once, 2. Then we have 3. 3 appears 1, 2, 3. So the frequency for 3 is 3. Then we have 4. 4 appears only once. Then we have 5, which appears 2 times. Then we have 6, which appears only 1. So from this frequency table, we can easily locate any item that has the highest frequency. So based on the frequency, we can be able to locate which one is our mode. So from here, we can understand that X, this 3 is our mode because it is the one that has highest frequency. Okay, median, which is the next item or the last one of the central measures of central tendency, is the measure of the exact midpoint of an observation or the exact middle number of any observation. So any data that we have, especially if it is raw, the first thing we are going to do is to check the nature of the data. Is it odd or is it even? That is the number of the appearance of all the items of the observation. So if it is odd, for example, we have odd number, which start with 1, 3, 5, 7, 9, 11, and the rest. Meaning that any one that cannot be divided without a remainder is an odd number. Then we have even number. If the observation is even, that means the one that can be divided without any remainder. For example, 2, 4, 6, 8, 10, and the rest. So when we check, we find that it is odd. Then we count the items of the observation and we locate exactly the middle number. And if we do that, then we have our median. But if it is even, then we have to use this formula, n plus 1 over 2. That is how to locate our median. So we have to take the two middle numbers, add 1 divided by 2, then we have our median. Suppose we are given this data and we are asked to find the median. The first thing we are going to do is to arrange it either in ascending order or in descending order. What we mean by ascending order arrangement of the data is to start with the lowest to the highest. For example, our lowest item here is 1, then followed by 2, 3, 4, 5. So if you arrange it in this way, then we count. We have 1, 2, 3, 4, 5. So this is an odd number. So how are we going to find the median? As I told you, the median is the exact middle number of the observation. So we count from the right to the left. For example, here from the left we have 1, 2, 1, 2. So therefore 3 is our median, because it is the exact middle number of the observation. And if we decide to arrange the data in a descending order, that is starting from the highest to the lowest, for example, we take 5, 4, 3, 2, 1. Then we apply the same process. That is by counting from the right to the left. Then we locate the exact middle number of the observation. So if we do that, then we have 1, 2, 1, 2. Then still we have 3. So 3 is still our median. But this is only possible if the observation we have is odd. But if it is even, then we have to use that formula that I said, n plus 1 divided by 2. Now, suppose we have this data and we are asked to find the median. So the next thing we are going to do is to find out how many items do we have in the data. Now, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is an even number, because if we divide 12 by 2, then we have no remainder. Now, the next thing we are going to do is since the data is arranged, then we locate the exact two middle numbers plus 1 divided by 2, then we have our median. Now, I start from the right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So these are our exact two middle numbers. Then we said median is calculated as n plus 1 over 2, since the observation is even. Then we said 12 plus 13 plus 1 all over 2. 12 plus 13 is 25, plus 1 is 26. So we have 26 divided by 2. 26 divided by 2 is 13. Therefore, median is equal to 13. Then we look at our observation. From this observation, we can easily locate our median, which is 13. So this is our median. I hope we understood how to find mean, mode, and median, which are the items in measures of central tendency. And this is the end of today's class. Till we meet again. Thank you.